Welcome back to the channel, everyone. Today is a major milestone in our full stack web development series. We are finally taking our restaurant online menu web application off our local development machine and deploying it live to the internet. If you have been following along with the series, in our previous video we set up our production database over on Supabase. Supabase provides a full PostgreSQL database with a very generous free tier, making it ideal for real-world production testing without paying anything upfront. For hosting our actual Flask application, we are using Render today. Render is extremely smooth for hosting Python web applications, and just like Supabase, its free tier is perfect for production testing and showcasing your live applications to potential clients or employers. Now, before we jump into the dashboard and hit deploy, I want to take a minute to address a huge topic for beginner and intermediate developers watching this. The production deployment stage is usually where most self-taught developers hit a wall and start to panic. You write code on your local computer, everything works smoothly, you test every feature, and it feels rock solid. But the second you push it to a remote cloud host, red error logs flood your terminal, the build fails, and the web service crashes. Here is the golden rule of web application deployment: do not panic when you see deployment errors. If your core application logic works on your local machine, 90% of all deployment failures are simply missing or mismatched dependencies in your environment. That is literally it. It is rarely a failure of your actual code logic, it is almost always just an environment configuration issue. Your cloud server is a completely clean, empty computer that does not know what packages your app needs until you explicitly list them in your requirements file. Once you master reading deployment logs and matching your dependencies to the production server environment, you will be able to debug and deploy any web application in under 30 minutes. Let us walk through the entire deployment pipeline step by step and debug our application live in real time. First, let us head over to the Render dashboard. Once logged in, click on the New button at the top right and select Web Service. Render connects directly to GitHub, so we will select our restaurant menu repository from our account list. Next, Render presents us with a configuration settings screen. This is where we tell Render how to build and launch our Flask application. There are two main fields you need to pay close attention to: the build command and the start command. For the build command, we type in pip install -r requirements.txt. This tells Render to create a clean virtual environment and install every Python library listed in our requirements file. For the start command, we need a production-grade WSGI server rather than Flask's built-in development server. In production, Flask's default development server should never be used because it is not designed to handle concurrent user requests safely or efficiently. So for our start command, we enter /app :app. Let us break down what /app :app means. The first app refers to the Python file name, which in our case is app.py. The second app after the colon refers to the Flask application instance created inside that file, which is app = Flask. If your main entry file is named main.py, your command would be main: app. With those settings entered, we click Deploy Web Service. This first deployment is what I call our baseline environment test. We hit deploy specifically to see what breaks, read the logs, and fix the environment step by step. Sure enough, looking at our deployment console, the build finishes, but the service immediately crashes with an error stating, command not found. Why did this happen? Because back on our local development environment, we might have installed Gunicorn globally or forgotten to include it in our project file. Render tried to execute the Gunicorn command, but Gunicorn was never installed in the remote container. To fix this, we head back to our code editor, open our requirements.txt file, and add Gunicorn == to 1.2.0 on a new line. We save the file, commit the change using git commit, and push it up to GitHub. Render automatically detects the fresh git push and immediately triggers a new build. Now we watch the second deployment attempt. Render installs Gunicorn, but then the build log throws another classic error, module not found error, no module named Sklalchemy. Again, do not panic. This is just another missing dependency. Flask SQL Alchemy and SQL Alchemy were powering our database models locally, but they were absent from our requirements file. We go back into requirements.txt, add Flask SQL Alchemy, commit the changes, and push back to GitHub. Now we wait for render to pick up the updated commit. The build step completes successfully, Gunicorn starts up, but then we hit our third common obstacle, a database connection error during application startup. When we check the stack trace, the application is failing to connect to our remote PostgreSQL instance on Supabase. By default, database connection you are starting with PostgreSQL : attempt to use older database adapters like Psychopage 2, which might not be installed or configured cleanly in our modern Python container. To resolve this cleanly, we implement Psychopage 3, which is the modern driver for PostgreSQL in Python. First, we add Psychopage with the binary extra into our requirements.txt file. Second, we update our database connection string variable. Instead of starting with PostgreSQL : we explicitly define the modern dialect and driver by formatting the connection string as PostgreSQL plus Psychopage : followed by your database credentials and Supabase host URL. We save our requirements file, commit the updated connection string handling, and push our final changes up to GitHub. Render kicks off the build once more. It installs the packages, binds Gunicorn, connects seamlessly to Supabase over Psychopage 3, and passes the health check. And just like that, voila! Our restaurant menu web app is officially live on the web with a fully functional remote database. As you saw today, deployment is not magic, and it is nothing to fear. It is simply a methodical process of matching your project dependencies to your hosting environment. Now that our website is live in production, our work is not quite done. In our next video, we are going to perform live production testing. We will test every API endpoint, make sure every button and user action responds instantly, verify that our CRUD database operations update in real time, and polish up our final UI styling so the platform is completely ready to pitch and sell to real restaurant owners. If you enjoyed this breakdown and learned something new about production debugging, please hit that like button, subscribe to the channel, and drop any deployment questions or issues you are facing down in the comments below. Thank you for watching, and I will see you in the very next video.